Hi, everybody. My name is Mike Della Selva, and we're going to talk about Chem 2 and the relationship between intermolecular forces, boiling points, and vapor pressures. First thing we notice is this little chart in the handout. This is a very important chart because this chart basically shows you the strength of the bonds. And what it says here is hydrogen bonding, which is NH, OH, or HF, is stronger than dipole-dipoles, which all sometimes are called polar molecules, which is stronger than London forces, or sometimes they call them instantaneous dipole-dipoles. This is important because this directly affects two properties, boiling points and vapor pressures. And the way they affect it is the stronger the bond, the higher the boiling point. So a hydrogen bond will have a higher boiling point than a dipole-dipole. The reverse is true. The higher the boiling point, the lower the vapor pressure. So London dispersion forces often have the lowest boiling points, but the highest vapor pressures. Now, some other facts related to both London forces and dipole-dipoles. London forces become stronger as the molecules become longer chain because as the number of atoms increases, there are more places along their length where instantaneous dipoles can develop. The second piece of information. London forces become stronger the less compact the molecules are. Compact shapes experience weaker London forces than long chains. So this means that this has a stronger London force than this. Third piece of information is London forces become stronger the larger the molecules are, as the charges on the opposite end of an instantaneous dipole are larger than in a small molecule. Some notes of information in regards to vapor pressure. We already talked about the first note, higher boiling points have excuse me, stronger their attraction, the lower the vapor pressure. Second, vapor pressures do not depend on the size of the container. And third, most physical properties depend primarily on the strength of the intermolecular attractions. Well, if we look at a state, solids are stronger than liquids, then are stronger than gases. This is just a FYI, viscosity increases as the temperature decreases. Now, we have to figure out, once we know the force, we can determine which one is stronger, but how do we determine the forces? This is a guideline. First thing is you determine if the structure has any hydrogen bonds. That's pretty straightforward. You just look at the structure, and if it has a hydrogen bond in it, you know it has hydrogen bonds. And remember, when you're determining the strength of a molecule, it's always going to be the strongest force is going to be the guiding light for the molecule. So if you have a molecule that has hydrogen bonds and dipole-dipoles, you're going to say it's a hydrogen bond. If you have a molecule that has dipole-dipoles and instantaneous dipoles, it will be defined as one that has dipole-dipole interactions. Plus, everybody should know that almost all molecules have instantaneous dipole-dipoles. Okay, so now, how do we determine? The first thing we have to do is to draw a Lewis structure. If you don't remember how to draw a Lewis structure, review your Chem 1 notes or come into the ASC and we will be able to help you out rather quickly. So the first thing you draw is the Lewis structure. You look at, and we'll take NF3 as an example. We draw the Lewis structure for NF3, and we then see that there are unpaired electrons on the central atom. And let me give you an example. Right here. That Lewis structure is polar because we have unpaired electrons on the central atom. Now, going back, if there are some other examples, there are two central atoms with unpaired electrons on both atoms, then the structure is symmetrical and will only exhibit London dispersion forces. Okay, example is nitrogen. We'll get into an example using oxygen. Now, if no unpaired electrons exist on the central atom and the structure is non-symmetrical, the molecule will be polar and have dipole-dipole interactions. Okay. If neither of these two are satisfied, then the structure will be symmetrical and will exhibit only London forces. And remember, all other structures will exhibit London forces if they have dipole-dipoles and or hydrogen bonds. So now let's go and see from visual examples what we have. Okay, now we just talked about this one. Now let's look at this one. This is CH4. Again, for everybody's benefit, these dashes are bonds, and they mean they're sharing electrons. So in this case, totally symmetrical. It's nonpolar. Now let's go to NH3. NH3, and again, the Lewis structures have been defined by me, and they have hydrogen bonding because this is one of the hydrogen bonds. Now, one of the things we're now looking at is CFCl3. It's polar because first of all, there are no unpaired electrons, so it meets that criteria, except it's non-symmetrical. The chlorine atom and the fluorine atom are different and will have different electron cloud sizes that will create some instantaneous dipoles as regular dipoles. Again, when you draw your Lewis structures, they tell you in the book that you should have 8 octets. I not wrote them in there. I'm focusing mainly on the central atom. Now the final example, oxygen. You say, well, what do I do? It doesn't have a central atom. That's true. However, it is symmetrical. You draw a line through here, and you can overlap it as mirror images. If it is symmetrical and it does not have a unique central atom, it will be nonpolar. Okay, now let's go back and go to the next phase, which we have some problems here. Okay, now what I'm going to do is ask you to look at problem 5 and problem 7 and draw the Lewis structure. I will draw it. Give yourself 30 seconds to put together the Lewis structure and also to determine in your mind what kind of force. Remember, the main force, the strongest force. Okay, let's go to this and look at 5. This is phosphorus trichloride. It's got 2 unpaired electrons. So we know this is going to be dipole-dipole. Look at number 7. We drew the structure, and there's no unpaired electrons in the central atom, and this is symmetrical. So this will be London forces. This is how you should do this exercise. Now, let me get back to and go through each one. Water, H2O. I'm not going to go through the answers. The answers are down here. Carbon tet, CCl4, ammonia, NH3, carbon dioxide, CO2. We just did phosphorus trichloride, nitrogen, N2. We did number 7, acetone, CH2O. This will be the trickiest one of these groups for Lewis structures. Methanol, CH3OH, and borane, BH3. Now, you can either try to do these now, and look at the answers here. So you don't have to rush, but these are the answers associated with each one of the problems here. Okay. Again, if you have, I'll call it some questions about our answers, please visit us at the ASC, and we're more than willing to help you out and able to. Or if you're a student here and you want to attend one of our virtual blackboards, you're welcome to do it. Now that we have successfully defined what it takes to have a force defined, we need to now go into something where we want to talk about the relationship of forces to vapor pressure and to boiling points. And that is going to show up in this section of problems. Okay, now I'm going to go through and talk about a couple of these. The yellow highlighted area is the right answer. So let's talk about number 1. Which compound will have the lowest boiling point temperature? Well, we know the lowest boiling point temperature will be the weakest force, right? Well, we look at this, we don't see any hydrogen bonds. So the discussion is going to be dipole-dipoles versus London forces. Well, if we look at A, B, C, and E, we know they're all dipole-dipole because they're non-symmetrical. However, if we look at D, we know this is a London force. So this will be the weakest force and will have the lowest boiling point. Now, let's go to, let's see which one. Let's go to, hang on one second. Let me just see. Let's go to number 5. Again, which compound will have the highest boiling point? Well, the highest boiling point will be the strongest. Well, the first thing we look at is hydrogen bonds. And in this case, we don't have to draw the Lewis structures. This is to save you time. You look at for the hydrogen bond. Okay, now you look at the other structures, and it's pretty obvious they don't have hydrogen bonds. So in this case, E is the right answer. Because it has a hydrogen bond, it will have the highest boiling point. Okay, these are the answers. If you have any questions, please visit us at the ASC or a virtual session, or we also have Ask Us capability, where you basically submit a question and we'll give you an answer in 24 hours. That is it for today's session. Thank you very much.